Okay, so hello and welcome back. So this is basically the beginning of where we talk about relations and functions. I hope that I haven't confused you too much. I'm parallelly creating videos for two different courses, and both of those courses happen to be from the same chapter, so I have to do a little bit of juggling. So I hope that I haven't confused you too much. Now, this is where we talk about relations and functions. Relations and functions. Chapter 1. Chapter 1 of Class 12. Class 12. And I already showed you how to basically download the book and the text for this course in the very first video of this playlist, so you are hopefully good to go. Now, in the beginning of this chapter, there is a quote from G.H. Hardy. It says, "There is no permanent place in the world for ugly mathematics. It may be very hard to define mathematical beauty, but it's just as true of beauty of any kind. We may not know quite what we mean by a beautiful poem, but that doesn't prevent us from recognizing one when we read it." And that's from G.H. Hardy. So G.H. Hardy, as you probably know, was a mathematician was an English mathematician who was a contemporary of Ramanujan, who was also an Indian mathematician. So G.H. Hardy is Godfrey Harold Hardy, FRS, was an English mathematician known for his achievements in number theory and mathematical analysis. And in biology, he is known for the Hardy-Weinberg principle. Why biology? A basic principle of population genetics. Now, he was born in February 7th, 1877 in United Kingdom, and he died on December 1st, 1947 in Cambridge, United Kingdom. And he was also a contemporary of Ramanujan. You see this picture over here. Ramanujan happened to go to England in somewhere around this time, where I don't know when exactly, but during the time G.H. Hardy was alive, Ramanujan was also happened to be alive, and Ramanujan happened to go there to England. He had all of these notebooks full of many types of different formulas related to the number theory and infinite sets and all those kinds of things. And he basically he showed his notes and everything to G.H. Hardy, and G.H. Hardy was very basically excited to see all of those formulas. And there is a story that you can of course follow on there is a movie called The Man Who Knew Infinity. You can follow the story in that movie. And well, the problem was that Ramanujan had an unusual habit of not proving any of his formulas and results. It seems that he just didn't know how to prove them, which is a little bit unusual. And so G.H. Hardy basically got him to prove some of those formulas, and then they worked together for some time. and then Ramanujan died at the age of about 31 or so. So that was basically the story of Ramanujan and G.H. Hardy. So now let's get back to basically our relations and functions. So as an introduction, we have recalled that the notation of relations and functions okay, so basically in the review videos that we did before this video, we talked about relations, we talked about functions, we talked about basically domain, we talked about the codomain, and we talked about the range of a function. And we talked also about some different, actually we didn't talk about these different types of specific real valued functions, but if you have taken basically if you have gone through that chapter, you already know a little bit about also basically different types of specific real valued functions and their graphs, which if it's necessary, then we will do a review of them as well. Now, the concept of the term relation in mathematics has been drawn from the meaning of relation in the English language, according to which two objects or quantities are related if there is a recognizable connection or link between the two objects or quantities. So basically a relation is, of course we have talked about the relation, you already know what the relation is, so I don't have to really talk about relations anymore. And if basically, for example, you can say that let A be the set of students of class 11. Let me make it myself, for example, let A be the set of students of class 12, which is not really of class 12 of a school. And let's set B be, for example, the set of students of class 12 of the same school. The set of students of class, this time 11, of the same school. Right? So then some of the relations from A to B would be, for example, then some of the relations from A to B would be basically, for example, number 1, you could say all the order pairs A comma B, such that well, you could say it this way. You could say all the ordered pairs A comma B that belong to the set A, for example, A times B, or the Cartesian product of A and B, such that, for example, A is a brother of B. A is a brother of B, for example. Or you could say, for example, all the ordered pairs of A and B, all the ordered pairs A and B that belong to the Cartesian product of A and B, such that A is a sister of B, for example. Or you could say, for example, all the ordered pairs, for example, A and B, belonging to the Cartesian product of A and B, such that age of A is greater than age of B, for example. Age of A is greater than age of B, right? Or you could say, for example, get some space over here. You could say, for example, all the ordered pairs basically A comma B that belong to the Cartesian product of A and B, such that basically total marks obtained by A in the final examination, obtained by A in the final examination, in the final exam, is less than the total marks, obtained by, for example, by B in the final exam. Right? So that would be another set over here. Or you could say that, for example, all the ordered pairs A and B that belong to the Cartesian product of A and B, such that A lives in the same locality as B. So now, however, we can say that, abstracting from this, we define mathematically a relation R from A to B as a relation R from A to B, as an arbitrary subset of A and B, as an arbitrary subset of A and B, subset of A, the Cartesian product of A and B, right? So now, basically, if the ordered pair A comma B belongs to R, meaning that it's some ordered pair under R, we say that A is related to B under the relation R. We say that basically A is related to B under the relation R, and we write it as basically A, R, B. So that means that basically A is related to B under R. A, R, B, right? So in general, basically A comma B belonging to R. A comma B belonging to R, we do not bother whether there is a recognizable connection or link between A and B. We do not bother whether there is a recognizable connection or link between A and B. As seen in class 11, functions are special kinds of relations. And well, I would say as seen in the review videos, functions are a special kind of relation. Okay, so in this chapter we will study different types of relations and functions. So what we do in this chapter is that we will study different types of relations and functions, and composition of functions, and also invertible functions, and also binary operations. So that's what we will do in this chapter, or basically in these videos. Okay, so I think I will end this video here, and then in the next video we will start with types of relations. So I'll see you in the next video, and thank you.